Assalamu alaikum dear students. Today we are going to discuss exercise 1.1. In previous lectures we discussed the types of relations on a set. Now here question number 1 is we have to check the relations, which relations on a given set are defined or reflexive or symmetric and transitive. Here part number 1 of question first is a relation R is defined on a set A where set is defined 1 2 up to 14, and this R is defined as set of all those ordered pairs, that is set of all xy's such that 3x minus y is 0. So this means that here R is subset of A cross A, and this R contains ordered pairs xy where x belongs to A, y belongs to A, and these are connected by 3x minus y equals to 0. Here the value of x may be 1 2 3 up to 14, and y may be from 1 to 14. Now when x is 1, because 1 belongs to A, this when we substitute in this equation 3x minus y equals to 0, y comes out to be 3. So this means that this R contains one element as 1 3. Similarly, if we put x equals to 2, this means that y equals to 3 into 2, that is because here 3x equals to y. 3x equals to y because 3x minus y is 0. So when x is 2, y is 6. So this means that here we have 2 6. Now when x is 3, y is 9. So it is 3 9 because both 3 and both 9 belongs to set A. Similarly, when x is 4, it is 3 into 4, that is 12. So y is 12. Now if we put x equals to 5, then y comes out to be 15. But here this set does not contain the element 15. So this means that this R only contains these four elements, that is 1 3 2 6 3 9 and 4 12. Because if we put x equals to 5, x equals to 6, y comes out to be an element which lies outside this A. So this means that R is here, this R only contains 1 3 2 6 3 9 and 4 12. So our this relation is actually this, which is same as this above, because this is the tabular form and this one is the tabular form of this given relation. Now here we have to check the reflexivity. Clearly R is not reflexive because here 1 belongs to this A and 1 does not belongs to this R, because this R contains only 4 elements, that is 1 3 2 6 3 9 and 4 12. So there exists an element 1 belongs to A such that 1 is not related to 1, that is 1 does not belongs to this R, hence it is not reflexive. Also here this R contains this 1 3, or 1 3 belongs to this R, but 3 1 is not in this R. So this means that 1 3 belongs to R does not imply us that 3 1 belongs to R. So there exists an element AB which does not imply that BA belongs to R. So clearly this R is also not symmetric. Now for transitivity, here we have 1 3 and 3 6, because in order to check the transitivity of a relation, we have to firstly find the elements of the form of A, B and BC. So here we have such types of elements like 1 3 and 3 9. Now for transitivity, these two elements should imply that third element 1 and 9 should belongs to this R. But here 1 and 9 is not in R, so this means that this R is not transitive. So in other words, this R is neither reflexive nor symmetric nor transitive relation. Now the second part of this, we have to check the reflexivity, symmetric and transitivity of this relation defined on N, that is on set of natural numbers, which is defined by xy such that y equals to x plus 5 and x is less than 4. So the conditions on these x and y's is simply y equals to x plus 5 and x is less than 4. We have to check this relation whether it is reflexive, whether it is symmetric or transitive. Here x is less than 4 because R is defined at xy such that y equals to x plus 5 and x less than 4. So this means that x equals to 1, x equals to 2, and x equals to 3. When x equals to 1, if we put in place of here in this equation, y comes out to be 6, so 1 6. When x is 2, y is 3 7, it is 2 7. And when x is 3, y comes out to be 3 plus 5, that is 8. So we have here 1 6, 2 7, and 3 8, only 3 elements. Clearly neither it is this symmetric reflexive, because one belongs to natural, one is in set n, one is not in this. So there exists an element one belongs to n such that one is not related to one. So clearly this is not reflexive. Now symmetric, 1 6 belongs to this R, but 6 1 is not in this R, so it is no, so it is not symmetric. Also here this relation is symmetric, transitive, because the reason is there does not exist an elements of the form of a, b, and b, c. So just like it is simply an empty set in terms of that elements of the form of a, b, and b, c. So in that ways we can say that this or is a transitive relation. Now the third one is if relation on a is defined by 1 2 3 4 5 6, where this or is defined by x y such that y is divisible by x. Now second y is divisible by x means x divides y, like 4 is divisible by 2 means 2 divides x. So from this we conclude that this r is actually 1 1, because 1 divides 1, 1 2, 1 divides 2, because 2 is divisible by 1, 1 3, 1 4, 1 5, 1 6 up to 6 6. So it contains only these elements. Now clearly for all a which belongs to this given set a, a belongs to this R. Why? Because second a is always divisible by the first a, because they are same, because every number divides itself or every number is divisible by itself. So this means that here this elements a contains 1 up to 6, so this means that 1 1 2 2 3 3 4 4 5 5 6 6 belongs to R. Hence it is reflex relation, because you can see this here we have all such elements, that is here 1 1, we have here 1 1, 2 2, 3 3, 4 4, and 5 5. Now for symmetric, here 1 3 belongs to this, because 3 is divisible by 1 or 1 divides 3, but 3 does not divide 1, hence 3 1 does not belongs to R, so it is not symmetric. Now similarly if a b and b c belongs to R, this means that a divides b, b divides c, implies that a divides c, hence ac belongs to R. So this means that we can say that this R is also transitive, hence this relation is only reflexive and transitive but not symmetric. There is second method to check this relation. Now for reflex relation, let a belongs to R, then a divides a. When a divides a means a belongs to R. When a belongs to R, a is any number, so this means that we can say that R is reflexive. For symmetric, if a divides b, when a divides b implies that ab belongs to R, but it does not mean in general, it does not imply as in general that b divides a. So ba in general does not belongs to or, hence it is not symmetric. Similarly for transitivity, let AB belongs to or means A divides B, and BC belongs to or means B divides C. Now when A divides B, B divides C implies that A divides C, hence AC belongs to R. So in other words, this is a transitive relation. Hence this relation, there are number of methods to check the reflexivity, symmetric, and transitivity of a relation on a given set. Now here the part fourth of this question is relation is defined on set of natural numbers, that is set of natural numbers which is z, defined by x y such that x minus y is integer. Clearly this is both reflexive, it is symmetric, and it is transitive relation. Because x minus y is integer, y minus x is integer, x minus x is integer, which implies that x belongs to R. Now when x minus y is integer implies y minus x belongs to R, so it is transitive. When x minus y is integer, y minus z is integer, implies that x minus z is integer. You can prove it by yourself. Now the fourth one is, we have a relation is defined on all set of humans, or relation is defined on a set of humans. The first relation is R is defined as xy. So this means that x is here human, y is human. X and y work at the same place. Now it is reflexive because x belongs to this set, that is x is the human. So this means that x is same as x, hence x and x works at same place. So this means that x belongs to R for all x, because x is same as x, so x and x works at same place. So this means that this is a reflexive relation. Similarly, transitive symmetric relation, let xy belongs to R. This means that x and y works at same place. Now x and y work at same place means y and x works at same place. When y and x works at same place implies that yx belongs to R. Now for transitive, let xy and yz belongs to R, which implies that x and y works at same place, y and z works at same place. Now in other words we can say that these three works at same place, or we can simply say that x and z works at same place, hence it is transitive also. Similarly, second relation on this set is defined as xy means x is human, y is human, x and y lives in the same locality, so it is same as the above. Now the part number C of this is xy means x and y humans, x is taller than y by 7 centimeters. We have to check exactly 7 centimeter taller than second. Clearly here x does not belongs to or for any x, because height of x is same as height of x, because they are same, or they are actually one, which implies that first x is not taller than second x by 7 centimeter. Hence this x does not belongs to or for any x belongs to this, or for any x equals to human. Now for the symmetric, if xy belongs to R, when xy belongs to R means that x is taller than y by 7 centimeters. In other words, we can say that y is shorter than this x by 7 centimeters. When y is shorter than x by 7 centimeters implies that yx does not belongs to this R. So when yx does not belongs to R, it implies that this is not symmetric. Also you can check it is transitivity, because if x and y belongs to R and y and z belongs to R, this means that x is taller than y by 7 centimeters, y is taller than z by 7 centimeters, means x is taller than z by 14 centimeters. Hence this xz does not belongs to R. So in other words you can say that this R is not transitive on this set of humans. So this was question first. Inshallah in tomorrow's lecture we will discuss the remaining questions of this exercise 1.1. So thank you.